This is the video guiding you through the homework on independence. This is a little tricky, but it's really instructive and it'll help you think through the power of really simplified models. So it starts off, in case you remember, you have to do the reading first. I assume you guys have tried this out. You're not just coming straight to the video. They have these very, very artificial assumptions, especially in today's racially charged times. Um, let's suppose you got a population just of black and whites. Again, highly artificial, but we'll start there with the model. Assume that 10% of each group is racist, right? Only 10%. 10% of whites, 10% of blacks. And let's suppose that white people are in the majority, black people in the minority, right? So, and these are just, again, unrealistic assumptions. 13% of the population are blacks, 87% are whites, and obviously they'll vary if you talk about what region of the, say, US or world you live in. So even with these highly artificial assumptions, majority white, minority black, and only 10% of each group racist, let's look at what the math will tell us, okay? The chance that a white person will run to a black racist on any encounter is 1.3%. Why? Because it's 10% of the 13%. 13% is the black population, they're in the minority. And remember, of each of the populations, white and black, 10% are racist. So the chance that a white person will run into a black person randomly is 1.3%. And that's a huge assumption too, that they're random. Very often, they're not random. So that means these numbers that we're getting artificially will in all likelihood, be much higher in the real world. And yet, even with this highly simplified model, we can get a sense of just how, from the numbers themselves, how disproportionate things are based on percentages of one minority and one majority, and even smaller percentages of races. Okay, so for the first one, in 5 encounters, what are the chances that W, a white person, will meet no racist, at least one black racist? What's the chances that one white person will meet at least one black racist in 5 encounters with black people, right? That's too hard to do, so you turn around, you take the complement. What's the chances that this white person will meet no racist on a single encounter? So you say, well, since the chances of encountering one black racist is, again, 10% times 13%, which is 1.3%, you say 1 minus that. So you transform that that percentage into a decimal, move it 2 places. So 1 minus 0.013 equals 0.987. This is the probability of W not running into any black racists. So now, since these are independent events, we say on 5 independent occasions, what are the chances of that happening? The chances of that happening are 0.987 times 0.987 times 0.987 5 times. So that's 0.987 to the 5th power. That equals 0.937 very roughly. Okay, and that's the probability of W not encountering any black racists in 5 meetings. So that means if you turn it around again, you take the complement of that, which is what we originally want. That must mean the opposite of not encountering any black racists. The opposite of not encountering any is at least 1, maybe 2, maybe 3, maybe 4, maybe 5, is 1 minus that number, 0.937, which is 6.3%. What you think about it, it's not bad. If whites are the majority and there's only 10% racists in each group, on 5 encounters from the majority for the minority, there's going to be a pretty low probability of encountering a black racist. It's 6.3%. That sort of accords with intuition. Okay, now for the other 3 numbers, that's what I've calculated here. It follows that same logic that I've laid out here. So let's try that. For the first one, 36.6%. By contrast, suppose now you're talking about in the minority, a black person. What's the chances of a black person encountering a white racist? Well, again, there's 87% white, only 10% are racist. You multiply that, you get 8.7%. So chances that a black person will encounter a white racist is 8.7% on a single encounter. So you turn that around and you say, suppose that this black person encounters no racists. So 1 minus, you turn that percentage into a decimal, 0.087 will be 0.913. And then you take that and you multiply it to the 5th power. And you're saying on 5 encounters with any person, what are the chances they'll encounter no white racists? It's that. That'll equal 0.634. Okay. And then you now subtract off 1 from that, because you don't want to know what are the chances that a black person doesn't encounter a racist, but what are the chances that they do. And indeed, they're higher because blacks are in the minority. The chances they encounter a white racist goes up to 36.6%. By contrast, again, on 5 encounters, the chances that one white person encounters a black racist is only 6.3%. Likewise for the rest. Now they say now let's bump it up, because you're not going to encounter just 5 people in your lifetime. In this case, you're going to encounter at least a lot. So they say now let's turn up to 25. And when you do the calculation for that first type, for a white person encountering a black racist, sure enough, the numbers go up. It goes up to 27% following that same type of calculation, 1 minus 0.013. Now you raise it to the 25th power. You subtract 1 off of that, and you get that. But then now look at this number. This is the shocking one. If you got 25 encounters of a black person with a white person, what are the chances that they'll encounter a racist? Well, again, 1 minus 0.087 gives you that. Then now you take it to the 25th power, and you take 1 off of that, 1 minus that, and it goes up from 36% to now 89%. This is just on simplified mathematical modeling. Hugely artificial. And yet it gives you some sense just from these numbers how likely an encounter, if you're in the minority, with someone who's racist is, even if there's only 10% of the population that's racist, which is quite artificial. People are probably much more racist than that, very often systematically, unconsciously, especially in places unlike Hawaii where things are much more homogenized. And even from these numbers, with greater interaction with people, you're going to get probably far higher numbers. So the power of mathematics, the power of logic, the power of reasoning can help illuminate, even just with these simple proportions, how things would work out. And it helps to shed some light on the situation that you find in, say, the US now and the world more generally. And when people say it's not racist or it's not this and that, chances are they're not really thinking very carefully. Because if you can get these numbers from these simplified models, with the world far more complex and interactive than it is, chances are the numbers are actually going to be much, much worse. All right, folks, this is part of the power of logic, probability, inductive logic. We've got other interesting exercises coming up, but this is one quasi real world example. See you next time.